Imagine your app is up, but it's frozen. Kubernetes thinks it's fine, but your user sees timeout. What if Kubernetes could detect that automatically and restart it? That's exactly what the Liveness Probes does. In this video, we will build one from the scratch with a real Python application and a real-world demo. In our previous video, we saw how to configure apps using environment variables, config maps, and the secrets. But once your app is deployed, keeping it healthy is just as critical as configuring it. So today, we will deep dive into Liveness Probes, what they are, how they work, and how you can build one step by step. Before we dive into code, let's understand what a Liveness Probe is and why it matters. Liveness Probe is a Kubernetes way of checking if your container is still alive. If the probe fails, Kubernetes restarts the container automatically. Think of it like a heartbeat monitor. If your app stops responding, Kubernetes revives it. Now that we know what a Liveness Probe does, let's see it in action. We will build a small Python application that simulates a real-world app freeze. So you can see Kubernetes self-healing at work. So I'm going to create one Python code in my system. So this is our Kubernetes cluster. So I'm going to create one file that is app.py. So this is our Python code. This is a simple app that runs an HTTP server on port 8080. It returns 200 OK for /health for the first 60 seconds. Then start returning 500. It's simulating a real-world app freeze. Our code is ready, but to run it in the Kubernetes, we need to create a container image. So first, let's create a Docker file and build our image. So right now, I'm using the RHEL server here. So instead of Docker, I'm going to use a Podman to build a container image. So let me save and exit this. And let me create one container file. So for Docker, we will be using our Docker file, but with the Podman, we need to use a container file. So container, it should be container file. And in this, so first of all, we need to use a from keyword and need to specify the image. So here I'm going to use a Python image 3.9 and the slim one. Then we need to create a working directory, that is /app, and need to copy the code, that is app.py, to the current directory. And then we need to run the command, that is python comma and the app.py. Now our container file is ready. Let's build an image. So podman build -t. So I'm giving a name, techinic /liveness demo v1 with a tag and dot, which depicts the current working directory for the container file. That means a container file resides in the current working directory. So Podman is not installed, so let me install it very quickly. Podman install -y. So Podman got installed successfully. So let's try to build an image again. So Podman build -t and the image name. So I'm going to use because my repository is on the queue. So I'm using a queue registry here. So I'm going to specify the complete repository name. So queue.io /nikhil811 /techinic and the tag, that is v1 and dot. So image is getting created. I think there is a typo in my container file. So let me open this. So it should be cmd instead of cmr. Save and exit. Let me create it again. Now image got built successfully. So if we want to see that, Podman images, and we can see the image got created successfully. Now we need to push it to our registry. For that we can use Podman push and the image name with the tag. So we need to log in first. So Podman login queue.io and the username and the password. I think I entered the wrong password. Let me try it again, and it worked fine. Let me push it again. So it's pushing an image to the registry. So our image got pushed successfully. Let's see it on the queue. So this is the image which got pushed a minute ago. Let's quickly come back to our console. Now the image is already pushed to our registry. The next step is to defining the pod in Kubernetes and configure the Liveness probe. So let me create a manifest file for the same. So vi liveness probe.yml, and let me update the content here. So this is our manifest file for the pod creation. If you notice, this is the same, but here we are using the image name, that is the one which we just created. And below that we have different block, that is a Liveness probe. So let me explain how it works. So creating a Liveness probe, we need to use a keyword called Liveness probe. So first we need to specify the HTTP GET. So Kubernetes performs an HTTP GET request on path, that is /healthz, and here if we see initial delayed second, that is 10. So it waits for 10 seconds after container starts before the first check. It give application a time to start. Then we have a period seconds, that is 5. It runs the check after every 5 seconds. Then we have a timeout second, that is 2. That means it fail if no response we will get from the application within 2 seconds. And at last we have a failure thresholds, that is 3. It restarts container after 3 failed check. And if you want to see the detailed information about that, you can refer the documentation for the Liveness probe from the Kubernetes documentation. So our YAML is set. So let's deploy it and watch how Kubernetes monitors our application and reacts when it becomes unresponsive. So let me save and exit and apply this manifest file, kubectl apply -f Liveness probe. So let me run the kubectl get pod with the watch option. So after a minute the app will freeze and the probe will start failing, and then the Kubernetes restarts the pod automatically. And let's describe the pod. kubectl describe pod, that is liveness-demo, and grep for restart here. And if you see, the Liveness probe got failed, and this is the event which we got from the kubectl describe command. So that means our application is not working properly, but Kubernetes will try to restart it automatically without any manual intervention. So let me run the kubectl get pod command again. So if you see, it restarted the pod 51 seconds ago. So that means there is no manual intervention required to restart the pod, and that's how self-healing works in action in Kubernetes. But where would you use this in a real world scenario? Let's explore with an example here. Imagine your application depends on an API or a database and the connection hangs. Instead of waiting for users to complain, Kubernetes restarts it automatically. That's where Liveness probes comes in the picture, and it will be very helpful in these kind of scenarios. So we have seen how Liveness probes bring your application back when it's unhealthy. But what if your application isn't ready yet? Maybe still connecting to a database, you don't want restarts, you just want to pause a traffic. That's where Readiness Probes comes in. Readiness Probes check if container should receive a traffic or not. In our next video, we are going to cover the Readiness Probes with a real world demo, just like we did with the Liveness Probe. And this was our Liveness Probe deep dive demo. And if you found this helpful, hit like and subscribe for more content like this. Thanks for watching. I will see you in the next one.